All right, today we are starting on page 14 in your packet. Mine looks a little different from yours because this question kind of shifted down from the page above. So we are going to talk about properties of parallelograms. This is 6-3 again on page 14, and you'll be happy to know that this is your last note video of 2021. So yay, we're just about there. All right, so first of all, a parallelogram is a special type of quadrilateral, and there's some properties that it has. It gets its name from the fact that it has two pairs of parallel sides. So AB is parallel to CD. Remember, it looks like a little arrow. And then BC is parallel to DA. All right, so the name of this thing, when you write it, this is important. First of all, the symbol for parallelogram is like a little mini parallelogram. So just draw two parallel lines like that and then connect the top and bottom. And when you name it, it doesn't matter which letter you start with, but you need to go continuously around like you're not picking up your pencil. So I always do it alphabetical. So I'm going to start with A, and it's going to go B, C, D. I can't say, oh, it's BCAD. You can't pick up your pencil. You could say BCDA because it goes right in a circle, but you need to make sure that you got your order down. All right, some other properties of a parallelogram. Opposite sides are parallel, which we just talked about, but they're also congruent. So let's say, if this is 3, this is 3. If this is 4, this is 4. As far as the parallel part goes, when we get into graphing, they're going to have the same slopes. Opposite angles are congruent. That means, if this is 60, this is 60 degrees because we're dealing with angles. And then a word you may not know, consecutive angles are supplementary. So that just means that angles next to each other add up to 180. So if this is 60, this is 120. Same up here. If this is 60, this is 120. All right, they're next to each other, either top to bottom or side to side. All right. The other thing is diagonals bisect each other. So that means they cut in half right here. So these are the same and these are the same. Not necessarily the same as each other. Like if this is 2, maybe this is 3, this is 3. All right, so let's do a little bit of practice with that. So we're going to find x in each figure. Again, mine's shifted to the next page. All right, so x, this would be 60. That's not what we're looking for. These are consecutive, so you just do 180 minus 60. So x is 120 degrees. All right, to find x in the next one, and your pictures might be a little bit light. The printer and copier were not being cooperative, so if you need to darken in any of this, feel free to. So x plus 7, opposite sides are the same, equals 15. Subtract 7, x equals 8. All right, and then the diagonals, remember, bisect each other, so this is the same as this. So 4x minus 1 equals 3x plus 4. And back to a little algebra. I'm going to subtract the 3x to be with the 4x. Something happened here. Just pausing on something. We're going to subtract the 3x, so it's 1x minus 1 equals 4. And then add 1 to both sides. X equals 5. And that's all you had to find. If you had to find each part of the diagonal, you could plug it in. And we'll look at some like that. All right, this next one's a little tricky because you got a lot going on. All right, first of all, I want you to think of this as a whole polygon without the diagonals there. Okay, angle L, since this is 36 and this is 50, all of angle L would be 86. Okay, so remember 86 and the 10x plus 14 add up to 180. So I'm going to set that up. 10x plus 14 plus 86 equals 180. And you have a lot more space on yours because it didn't shift. So when I combine those, 10x plus 100 equals 180. Subtract 100. 10x equals 80. Divide by 10 to get x equals 8. And it does want us to just find x and y. But sometimes if you have, extra lines in there, it's not as easy to see that relationship. So you just need to know that these always add up to 180. Now, because these are parallel with each other, well, here's a parallel line cut by this transversal here, right? This angle and this angle are going to be equal. So y is just 50. So x is 8 and y is 50. All right, so really things either add up to 180 or they're equal. All right, on this one, we've got two variables as well. Opposite angles we know are the same, so I'm going to do 2x minus 5 equals x plus 35 to start. I'll subtract x to be with the 2x. 2x minus 1x is just x minus 5 is equal to 35. Add 5. X equals 40. All right, now to find your y's, they're on the sides. Opposite sides are the same. So I'm going to set them equal. 3y minus 2 equals 2y plus 6. If you're struggling with the solving part, you really need to come and see me because it's just going to get harder. And it's actually a lot easier if you know how to solve equations. And I know last year was a little different and difficult with COVID. So, it might just take me going over a couple questions with you. All right, we'll subtract the 2y. We're left with 1y, or y minus 2 equals 6. Add 2. Y equals 8. We're done. Again, if it wanted you to find the angles, you'd plug it in. If you wanted to find the sides, you'd plug it in. All right, this one's easy. 98 and y are the same. 98 degrees. 90s band. All right, x is consecutive to those. It means next to them. So it's 180 minus 98, no matter which way you look at it. So it's going to be 82 degrees. That's a 2. What's going on here? All right, let's look at just a couple more here with some diagrams that we have to draw. Again, yours is right here, but this shifted to the next page. That's okay. So this was on page 15 at the bottom. So parallelogram KLMN. So again, easiest way to draw a parallelogram, draw two parallel lines and then connect the top and bottom. Now when you go to label it, it doesn't matter where you start, but it is important that you go right around. Oh, your picture should be there actually. I'm noticing my picture's not. So I'm just going to label mine quick. So notice they had K, L, M, N. All right, it goes right in a circle. L was 2z minus 3 in the picture. Wait, where is this? I guess this is really... Oh, I'm looking at the wrong page. I swear I'm losing it today, guys. You don't have a picture. I lied. I'm looking at the wrong page. It happens. All right, so again, it doesn't matter where you start, as long as you go in order. Maybe you started the K down here in the bottom, then it would go K, L, M, N. Doesn't matter. And maybe when you're done, you should have drawn it the other way because it looks wrong, but that's okay. LM is 28. LN is 26. So that's a diagonal. And the measure of angle LKN which is this guy up here, 74. Oh, see, we drew it the wrong way because that's obtuse, but that's okay. So angle NML down here is also 74. I'm just going to answer that question now. All right. KN is also 28. They're opposites. Now LO, they didn't draw. Basically what's happening here, O is the inner section of your two diagonals. And remember, they cut each other in half. So if this whole thing is 26, then this is 13 and this is 13 because they bisect each other. All right. Sorry about that confusion there. All right, turn to the next page. I believe we're just about done. Yep. Okay, so we've got our parallelogram. Again, diagonals bisect each other. So 3W is the same as W plus 8. Subtract W from both sides. So we have 2W equals 8. Divide by 2. W equals 4. Again, if this is too fast for you, come and see me or pause the video. Okay, you gotta be able to solve equations. All right. And then I'm going to go the other way. 4z minus 9 is the same as 2z. A little harder of an equation. I'm going to, since 2z is all alone already, I'm going to just subtract my 4z over. So now I have negative 9 equals negative 2z. Now I'm going to divide by negative 2. Negative divided by negative is positive 4.5 for z. You want us to find JG first. All right, JG is W plus 8. Well, W was 4. So 4 plus 8 is 12. For FH, ooh, that's the whole thing. So we got to plug it in and find each part. So 2 times Z, 2 times 4.5 is 9 for this section. Let's double check and make sure we get 9 over here. 4 times 4.5 is 18, minus 9 is also 9. So if I want to find all of FH, 9 and 9 gives me 18. All right, last question is on the bottom of your page 16. It got bumped to my page 17, but that's okay. So it says 3 vertices of parallelogram PQRS are here. Find the vertex, the coordinates of vertex R. Well, if you have points, plot them. Negative 3, 2, go back 3, down 2. Make sure you label, that's important. Negative 1, 4. Label. 5, 0. Now, if you're not sure which axis it goes on, look at this. Every point's an XY. 5's in the X spot, so it should be on the X axis. And that's S. Now let's think about a parallelogram here. R is going to be somewhere up here. And I know that because it goes in this order. P, down here, Q, R, S. Well, you also know that things are parallel, which means that they have the same slope. So if we can figure out what the slope is to get from P to Q, it'll be the same to get from S to R. So I'm going up 2, 3, 4, 5, 6 over 2. So I'm going to go up 6 over 2 to find R. It should be the same for PS to QR. I'm going up 2 over 7. Well, here I'm going up 2 over 7. Excuse me, up 2 over 8, up 2 over 8. It's the same thing. So I'm going to just connect my points. Oops, I don't want that. I want a line. And you'll see that you have a parallelogram. Now answer the question, what are the coordinates of R? It's the point 7, 6. All right, so we're going to stop there. We'll do the practice coming up. As you'll notice in your packet, these are very light, so we'll take some time to, make sure that we have the right values there. If you have any questions, let me know or stop by the math lab. If you want, pause the video here to get these values. Make sure you can see it on your paper. And then pause the video again to find any of these values here. Make sure that you have the right ones down on your paper. Okay, I will see you in class. Have a great day. And again, if you have questions, let me know.